Hi friends, today let's look at the problem subsets. So here's the description. Given a set of distinct integers, return all possible subsets, and elements in the subset must be in non-descending order, and the solution set must not contain duplicate subsets. So here we have an example where if you have you have an array of integers like 1, 2, 3. The solution should be an empty set with 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. Okay, we can have a look at the test case where you have an array, you call the method, which currently throws an exception, and then this is the expected result. Because the sequence doesn't matter, you can create a set, but the sequence inside of the list matters. So we use the list as the element of the set. So of course, first we have an empty list, then we have a list of element 1, then we have the list with element 1, 2, 1, 3, 1, 2, 3, and so on. Last, we call an assertion to compare the expected set and our result. We will insert everything into a set, so the sequence of those lists doesn't matter. Another test case will be the integer that only has one element. So we should have an empty list and another list whose only element is 1. Again, we call an assertion. Let's run both test cases. We should see both of them fail because we haven't written the logic. Yes, okay. Let's analyze how are we going to approach this problem. And first of all, we have an array 1, 2, 3. One approach we can use is to, let's start with an empty list. Then we can count all the lists that starts with number 1. For example, 1, 1, 2, 1, 3, and 1, 2, 3. And then we can start counting the lists that start with number 2, 2, 2, 3. That's it. Third part, the last step is look at lists that start with number 3. Of course, 3 is the only one. Okay, there are many approaches, there are many ways to solve this problem. But today we want to look at this approach, which is very similar to a concept called depth first search, or DFS. If we list all the subsets, make them like a tree structure, which will help us understand how are we going to approach. So the empty set will be the roots of the tree. Then start from there. We can have elements. We can have sets that only has one element. 1, 2, 3. So this looks like a tree. And then from 1, we can have 1, 2, 1, 3. From 1, 2, we can have 1, 2, 3. From 2, we can have 2, 3. From 3, that's it. So if we look at the sequence of the approaches, the steps we are finding all the subsets, it's quite similar to a concept in graph. It's called depth first search. First, we start from the roots, then we count, then we go to 1, then 1, 2, 1, 2, 3, and then we come back then we traverse to 1, 3, and 2, 2, 3, and 3. If we make it, so the sequence is like this. So this is very, very similar to the depth first search for tree traversing. And but how can we keep track of the element we've already counted? For example, we've already added, for example, when we are at the node 1, then we go to node 2. How do we know node 1 has we've already visited node 1? Here we can create something called an index called start index. This will start from 0, for example, in this place. It's start from 0 in this place, so it's 0, and then so we can visit the first one. But because the first element has been visited, we change the start index to 1, and then now after we come back and traverse again, we noticed that first element has already been visited, so we start from 2. Okay, cool. So let's look at some code. Let's write some code. So let's remove the exception we're throwing. First, we want to check the parameters that we're passing in. If that's null, we need to return an empty set. Actually, the set with an empty list. If it's null or there's no element in there, which is length equals to 0, we need to return a list with one element. That one element is an empty list. So notice we are not doing something called new array lists, because every time we call new array list, we are creating an array of 12 objects, which is a waste of memory. So here we are doing the nice way of creating a singleton list, an empty list, which saves us a little bit of memory. So because there's a requirement, must be in non-descending order, we want to sort the array. And now we need to create a helper method. Let's call it find all combinations. And I will explain the definition of this method later. Let's just write down all the parameters we will need. Create the method. Start indexed. Integer combination. Okay, let's explain what we are doing here. Let's look at the diagram. Remember, we start from the empty root, the empty set as a root. So here's the combination. So we are passing an empty list as the combination. And start index we just explained. So every time, so say we start from the number 1. The combination we're passing in is the subset with 1. We want to add more elements to that combination. Now that 1 becomes 1, 2, like 1, 3, and 1, 2, 3 on top of 1, 2. So that's what we are doing. Let's start from an empty list. So let's define a result. new array list, and new array list. And remember, when we are so when we are doing a depth first search and we just arrived in this node, we want to add before. So first, let's just we actually need to add this combination into our sets, because we are visiting the root. So we are doing a depth first search. We are visiting the root. So we want to add the root into our result. And if our start index is larger than the month's length, which means we've finished visiting all the elements, we should return the results. And we can do a for loop. Remember, notice here we should start from the start index, because everything before start index has already been visited. Now here now we've already visited the root node. We need to add all the children nodes. We need to visit all the children nodes and add them to our combination. So final list integer. That's called a new combination, which is the root nodes combination plus the children node, the child node, which is new array list, and everything in the combination. You might want to ask, why don't we just do something like this? Add the child node. This is because how it works in Java memory. If we draw a diagram, say this is the stack, this is a heap in the JVM. And we're calling a method, we are pushing the method to the stack. It's called method 0, method 1, method 2. Because every time, let's say you've already got the element 2, now you want to add another subset, is 2, 3. So say method 1 already created an object which has element 2. If we are doing this, we are not creating a new object. We're just operating in the old object. Now we are changing it to 2, 3. So in the end, what we will not have a set of many lists. We will just have a set of 1, 2, 3. So what we really want to do is method 0, we create an empty set, and method 1, we want to get 1, 1, and in method 2, we on top of that we want to create another array, 1, 2, and yep. So by doing so, we must create a new object, which is what we are doing here, creating a new array list. Okay. So we've already got this combination. Now let's just add numbers, nums. I. Now we can do a recursive call. Let's add. Find all the combinations. The elements will stay the same. Notice here it's very important. The start index becomes I plus 1, and the combination is the new combination. Now we can return the results. Let's run the test. Both pass. That's very good. We can use the diagram to demonstrate what we are doing here. So here, method 0, we get the empty list. Method 1, when we are doing the for loop to traverse each element. So right after we get the number 1 here, we call add all. We make another recursive call, which will call method 2, and then 1, 2. And this one will make another recursive call. We'll add in 1, 2, 3. And of course, we want to collect all this result in the result we are returning, this is why we create results and add all of them. Now, when this method 3 returns, it will be popped from the stack. And method 2, because we are doing the for loop, and at this moment, the start index is a start index. So here, we called I plus 1. When I is 0, we add in the 1, 2. Now when I is 2, we should, this is when I is 1. Now we see when I is 2, we should create another subset, and that will return. Method 2 is done. Method 2 will be popped from the stack. We're back to method 1, which will continue to go through the loop. 1, 2, and we will call method 2. This 2 will lead to create 2, 3, and method 2 will return. Will be popped. Method 1 will create 1, 2, 3. Now we've got everything. This is how it works. Thank you for watching. This is Eric.